I am now going to look at fractional indices. Now, some expressions can contain fractional indices. If that happens, we need to use a different mathematical process that may involve more than 2 steps to solve. And I'm going to explain that using these examples here. So I'll start with the first example here. Evaluate without using a calculator. Remember, we are not using a calculator. Now, to work out these questions, we will use this formula here, a to the power m, n is equals to a to the power m, n. So if you have a power over power, you can, all you have to do is multiply the indices. We learned that previously. So this is really not new to you. I'll just put it somewhere there. Now, in this first question, we have 4 to the power 3 over 2. So the first step is to express 4 as a power of 2. We know that 2 multiplied by 2 is 4, and therefore 2 squared is 4. So instead of writing 4, we'll write 2 squared in our question here. So what I mean is, instead of writing 4, I write 2 squared to the power 3 over 2. And remember what I said, if you have a power over power, you multiply the exponents of the indices. So 2 to the power of 2 multiplied by 3 over 2. Now, if you have, look at this point, you have 2 multiplied by 3 over 2. Now, 2 multiplied by 3 over 2. If you remember multiplication of fractions, 2 is same as 2 over 1. And if you multiply fractions, you can just multiply the numerators and multiply the denominators. You end up with 6 over 2, which is 3. So instead of doing all this process, all we can do is, if we have a question like this one here, 2 multiplied by 3 over 2, you can just cancel this, and then you end up with 3 as your answer, which is basically that. So you don't have to go through all this process. So what I mean here is, we can just cancel this 2 and 2 on condition that there's a multiplication sign in between them. We can cancel them, so we'll end up with 2 to the power 3, because what's remaining there is only 3, and that will be our final answer. The next question, you have 4 here, so I'll express 4 as a power of 2, so 2 to the power of 2, 2 to the power of 2 to the power 5 over 2. Same thing, go ahead and multiply the exponents because you have a power over power. So we'll end up with 2 to the power of 2 multiplied by 5 over 2. And then you cancel 2 and 2, just like what we did in A. Then we'll end up with 2 to the power of 5 as your final answer. Remember, this is 5 here. Okay, in C, we have now 2 multiplied by 2 multiplied by 2 is 8. So 2 cubed is 8. So instead of writing 8, we can just write 2 cubed here. So instead of writing 8, we'll just write 2 cubed. That's exactly what I'm going to do. So 2 to the power of 3 to the power of 2 over 3, which will be equal to, we have a power over power, so we use this formula here to simplify the power over power. So 2 to the power of 3 multiplied by 2 over 3. Cancel these guys the way we did the previous questions, so remain with 2 to the power of 2 as your final answer. The final question, same thing, 8 is 2 to the power of 3. Now, if you remember, if you notice from what we are doing here, we start by expressing whatever base that we have. If we have 8, we express it as a power of 2. Now remember, 2 is a prime number, so basically expressing it, that number as an index whereby the base is a prime number. So here we'll end up with 2 to the power of 3 multiplied by 5 over 2. And, sorry, made a mistake here. This is 3. So this is 3 here. So 5 over 3, which will be equal to, now before I even move on, we are multiplying this guy, so we can cancel that and that. So I'll end up with 2 to the power 5. And that will be my final answer. So the first step, express 8 as a power of 2, multiply your exponents, cancel where necessary, and you end up with your answer. I'll move on to the next example. Here you have 16. So the first step is to express 16 as a power of 2. Of course, you know that 2 multiplied by 2, multiplied by 2, multiplied by 2 is 16. So 2 to the power 4 is 16. So instead of writing 16, we'll just write 2 to the power 4 in our question. So 2 to the power 4 to the power of negative 3 over 4, which will be equal to 2 to the power 4 multiplied by negative 3 over 4. Now, same thing, cancel that and that, gone. We end up with 2 to the power negative 3. Now, if we want to write our answer without that negative power, we can use our knowledge on negative indices to simplify that as 1 over 2 to the power of 3. Remember here we are without using a calculator. You can actually simply, you know that 2 to the power 3 is 8, so you can say 1 over 8 is your final answer. And then for B here, you have 2 to the power of 3, so end up with 2 to the power of 3. So 2 to the power of 3 to the power of negative 2 over 3, which will be equal to 2 to the power of 3 multiplied by negative 2 over 3. Same thing, cancel those guys. So you end up with 2 to the power negative 2, which will be equal to 1 over 2 squared. And you can write that as 1 over 4. Next question, you have 27 is 3 cubed. You can check that if you want. To the power of negative 4 over 3. So remember, the first thing is you need to express that number that you have, the base that you have, as a power of a prime number. Remember, 3 is a prime number, 2 is a prime number. So that's the first step. And then what you're going to end up with here is 3 to the power of 3 multiplied by negative 4 over 3. Then we cancel these 3's. We'll end up with 3 to the power negative 4, which will be equal to 1 over 3 to the power 4, which is 1 over 81. And then the last one, we have 2 to the power of 2 to the power negative a half, which will be equal to 2 to the power of 2 multiplied by negative a half. Now a half of 2 is 1, so we'll have 2 to the power negative 1 because you have a negative there, which is 1 over 2. That is our final answer. So that is how you work out those questions. That's the mathematical process involved in solving indices that have fractions. I'll look at the last example and share a few tricks on how you can solve this kind of question. So A, to solve this kind of question, what you need to do is, first of all, get rid of the negative power. So we'll have 25/16 to the power a half. So the first step that I did was to get rid of the negative power by swapping the numerator and denominator. Remember, we learned that in negative indices. Now this is the same as, now what we have here is everything to power a half. So that means 25 to power a half and 16 to power a half. Everything in the bracket to power a half. So the numerator to power a half, the denominator to power a half. And then we can carry on and say 25 is 5 squared to power a half over 16 is 2 to power 4 to power a half. Then you can carry on. I won't be running out of space here. Just move down a little bit. If I can just move there. Good. That will be good. Okay. So this will be equal to 5 to power 2 multiplied by a half over 2 to power 4 multiplied by a half. Now, if you look at this question here, a half of 2 is 1, so that will just be 5 over, I think I'm running out of space, so I'll just try and write it here. Create more space. So that will be equal to 5 to power 1, because a half of 2 is 1, over 2 to the power of 2, because a half of 4 is 2, so 2 to the power of 2, which will be equal to 5 over 4. Okay, next question. The first step is, again, to swap the numerator and denominator. That will help us to get rid of the negative power. So this will be equal to 49 over 100 to power 3 over 2. And everything in the bracket is the power of 3 over 2. So that means you have 49 to power 3 over 2 over 100 to power 3 over 2, which will be equal to 7 squared to power 3 over 2 over 10 squared to power 3 over 2, which is 7 to power 2 multiplied by 3 over 2 over 10 to power 2 multiplied by 3 over 2. Now, if you remember our trick from the previous questions, you can cancel these guys and cancel those. So you'll end up with 7 to the power of 3 over 10 to the power of 3, which is equal to, now 7 to the power of 3 is 343. If you're not sure, you can use your calculator, and then 10 to the power 3 is just 1,000. So that's how you work out. The process is long, yes, but we're just using the knowledge that already covered. There's really nothing new that you're applying here, apart from how to do it. Like, you need first of all to get rid of the negative power before you start simplifying to end up with a fraction that does not have indices on it. Okay, the last question you have, first of all, we need to get rid of the negative power, so 64 over 27 to the power of 2 over 3. After that, what we have to do is, it's everything to the power of 2 over 3. So you have 64 to the power of 2 over 3 over 27 to the power of 2 over 3, which will be equal to, now 64 is actually 2 to the power of 6. So 2 to the power of 6 power 2 over 3 over 3 to the power 3 to the power 2 over 3, which will be equal to, now that's a 2, and that's a 6. This will be equal to 2 to the power of 6 multiplied by 2 over 3 over 3 to the power of 3 multiplied by 2 over 3. We can cancel. 3 and 3 gone. 3 goes into 6 twice. So 3 goes into 6 twice. That's how I'm cancelling it. So you'll end up with 2 to the power of 4 over 3 to the power of 2, which will equal to 16 over 9. And that is how you use knowledge on indices to simplify fractional indices.